So what is Spring Framework? What is Spring Boot? What is the relation and difference between Spring Framework and Spring Boot? Well, Spring is a Java framework that provides comprehensive infrastructure support for developing any Java applications, either standalone applications or, in our case, web applications. Spring handles the infrastructure so Java developers like you guys can focus on the application. Simply put, Spring Framework makes Java application development simpler and easier. Spring Framework is also time-tested and proven reliable in enterprise-level application development. It turns out that the Spring Framework is divided into more than 20 modules, as you can see in this picture. You don't have to use every single of them. You only pick important modules you use in your application. Those modules are grouped into Core Container, Spring Data, Spring Web, Spring AOP, Aspects, Instrumentation, Messaging, and Spring Testing. Remember, you don't have to use all those modules. You only pick the modules you need. If you take a look at this picture here, the foundation of this entire Spring framework is the core Spring container. It is also referred to as the Spring application context, which controls how an application's components are wired up. So what do I mean by that? If you still remember when we talk about Vue.js components, we discussed a topic called component-based development. Well, in that topic, I said any non-trivial application is composed of many components, each responsible for its own piece of overall application functionality, coordinating with the other application elements to get the job done. This concept looks beautiful on paper, but there is a small problem in component-based development. That is component dependency management. So let me show this concept in PowerPoint. As I said before, any non-trivial application is composed of many components, and those components will work together or collaborate to get the job done. For example, this is my application that has 5 components. In this context, you can think of each component as a Java object. So we have A, B, C, D, and E. And there are dependencies. For example, A depends on B, B depends on C, D depends on E. So this one really gives you a dependency graph of my application. What do I mean by dependency? So let's take a look at B and C. B depends on C. We call C a dependency and B a dependent. So that means B needs the services provided by C to work well. If C is not working, B will not work as well. And same thing here. If B is not working, A will not work. So without Spring Framework, when this application is run, those objects or components somehow need to be created using the keyword new in Java and introduced to each other. We're going to introduce C to B and B to A. As the developer of this application, you will have to do all those tasks. For example, if B wants to use C's service, B is responsible for creating an instance of C using the new keyword. Then in B, you can use C.API and use the service provided by C. This dependency graph can become very complex when my application grows. Then people start to think, can I simplify this process? Can I design an infrastructure object, also known as a container object, that contains all those components or objects and is responsible for creating and managing all those objects? No problem. That's the Spring Core Container. By the way, in Spring Framework, those objects or components are called beans. So from now on, I will call them beans instead of components or objects. Then how does this work? Based on the dependencies specified by each bean, for example, this bean tells Spring, I need this bean to work. And this bean tells Spring, I need this bean to work well. So when the application is started, when the application is run, Spring will be responsible for creating the dependency beans and inject them into the bean that need them. Or we can say to inject them to the dependent beans. And this is what I mean. Look at those green arrows. So this bean B says, Spring, I need a bean C. And Spring says, no problem. I will create this bean for you and inject them into this bean here. So in this bean, you can use the service provided by this guy here. So all those beans are wired together. You can think of this term wired inside a Spring context or Spring container to make a complete application. I'm pretty sure you're wondering, how does Spring do this, right? It looks like magic. It's really elegant. The act of wiring beans together is based on a technique known as dependency injection, or DI. Now, this is not unique in Spring. Actually, many other languages also have the same idea, the DI, dependency injection. It means rather than having a bean create and maintain the life cycle of other beans that they depend on, a dependency injected application like Spring Framework relies on a separate entity, which is this container object, to create and maintain all the components, all the beans, and inject those into the beans that need them. And this is done typically through constructor arguments or property accessor methods like setter. I will show you an example later on. So I hope everyone understands this dependency injection idea and how Spring Container manage all those beans and wire them together. This is super important. This is the foundation. Next, let's go back to lecture notes and I'll show you more modules in Spring Framework. So on top of the core container, Spring offers Spring MVC, which is a web framework, a variety of data persistence options, a security framework, integration with other systems, runtime monitoring, microservice support, a reactive programming model, and many other features necessary for modern web application development. And of course, we cannot cover all of them, but I just want to let you know that it is possible. Spring Framework is really a family of modules that is way enough for developing the modern web applications. Well, in this lecture, we'll talk about modules like Spring Web MVC, Spring Data JPA, and Spring Security. As I mentioned before, the technique that supports wiring beans together in Spring's core container is called dependency injection, or DI. An injection is the passing of a dependency bean, usually a service, to a dependent object, a client. So you can think of the dependency part in the dependency relationship as a service, and the dependent as a client. So the client wants to use the service provided by the dependency. So passing the service to the client, rather than allowing a client to create or build or find the service, is the fundamental requirement of the pattern. This will simplify your development process. As I always said, Spring makes Java programming or Java development much easier. Okay, that's why we need dependency injection in Spring. Here, I include a very good article. Okay, I read it when I first learned Spring's dependency injection. It is from Martin Fowler. If you're really interested in this pattern and want to know more about this dependency injection pattern, I highly recommend you read this article.